Okay, let's look at the homework 3.3, problem number 4. Right, so we have this function given, f of x equals 9 cosine squared of x minus 18 sine of x. X is between 0 and 2 pi. Right, so let's look at part A. We want to find the interval on which f is increasing and also interval on which f is decreasing. Right, so let's do that. Alright, so in order to talk about increasing, decreasing behavior of the function, we need to look at the derivative, right? First thing I would actually do is, since both of them have 9 in it, so I'll pull out 9, right? Then you have cosine squared of x minus 2 sine of x, right? So let's take the derivative from here. So f prime of x is equal to, right, 9, just a constant multiple, put that there. Then we take the derivative cosine squared, so it's a 2 in front, cosine of x. Then you have to multiply by derivative of cosine, which is negative sine. So negative sine of x, right? Then I'm going to just change this to a square bracket, like that. Right, then it's so we have the derivative of that, and the derivative of negative 2 sine x would be negative 2 cosine of x. Right, so we have that. Then you can see that we can factor out. So what's in common? We know that there's a 2 cosine of x sitting right here, and it's another 2 cosine of x there. So I'm gonna pull out the negative sign as well. So here's a negative sign, right? So this is going to be negative 2 times 9 would be negative 18, and also you have a cosine of x, right? Then what's left from the first term is a sine of x, right? So that will take care of this guy, right? Then here, negative 2 cosines factored out, so you have a plus 1. Oops. Plus 1 from the second term. Right? So let's set that equal to 0 to find the critical numbers. Right? So this will give us a couple of conditions. First, we can make cosine of x equals 0. Or here, sine equals negative 1. So you have a sine of x equals negative 1. Right. Alright, so cosine becomes 0. We know that this is going to be x is either 90 degrees or pi over 2. So cosine becomes 0. And also 3 pi over 2. Right? If you want, we can look at the unit circle. So let's draw a unit circle here. Alright, so we have a unit circle. Alright, maybe I should do this. Alright, so unit circle there. Alright, so we have 1, 1, negative 1, negative 1. Right, and that's the origin. Right, so we know that the cosine represents the x-coordinate of the point on the unit circle. So we want cosine x-coordinate to be 0. So we are talking about the point here and also point there. So you can see that the angle that we are talking about is here. This is 90 degrees, which is pi over 2. Right, then you can go pi over 2, 2 pi over 2, and 3 pi over 2. So that will be 3 pi over 2, right? So that's that, between 0 and 2 pi. All right, then we want sine to be negative 1. Sine is a y-coordinate of the point on the unit circle. So negative 1, so it's right here. So this is actually is going to give you exactly the same value. So x equals 3 pi over 2. Right? So we basically have two critical numbers, pi over 2 and 3 pi over 2. Right? So what we can do is we can do a number line. Right? So we have a number line here. Right? Then we're going from only 0 to 2 pi. Right, then we're going to put the tick marks using those critical numbers. So it's a pi over 2, so it's got to be over here. And here 3 pi over 2, so it's around, let's see, around here. Right, so it's a 3 pi over 2. Alright, then we need to look at the sign of the f prime. Right, so look at the f prime. Alright, so we can actually we can try a specific sample value, but we just know that here this is angle less than 90 degrees. So let's look at that. Right, so here's the derivative. Maybe I should write that down so that we can determine the sign. So f of x, and I would use this factored out version. So it's negative 18 cosine of x times sine of x plus 1. Alright, so here, negative 18, so that's always negative, so we know that. Right, so let's look at cosine. Right, so we're talking about angle between 0 and 2 pi. So here, cosine value is x coordinate, so that's going to be positive. So this guy is going to be positive. Alright, sine of x, it's here, sine of x cannot be negative 1, so this is going to be actually positive 2. Alright, so this is positive. Right, so you have a negative times positive, so that would be negative. So you have a negative sign on this interval. Right, so anywhere between pi over 2 and the 3 pi over 2, we can use pi, but so anywhere between pi over 2 and the 3 pi over 2. Right, so let's determine. So this is negative. Right, cosine between here and there is actually negative. Right, so here this becomes negative. Right, then here this says never negative, so it's positive, so it's negative negative positive, so you have a positive sign there. Right, then after that you see that between 3 pi over 2 and 2 pi, so we're talking about angle there. Right, so let's look at the sign here. Right, so that's negative. Cosine becomes positive there. Right, so this is never negative, so you have a negative positive positive, so that would be negative. Alright, now we have this guy. So we know that where this is increasing and decreasing, so we can look at the original function. Right, then since the derivative is negative, which means that the original function is decreasing here. Here it's increasing there, and here it's decreasing there. Right, so we know that the function is increasing on pi over 2 to 3 pi over 2. So therefore f is increasing on pi over 2 to 3 pi over 2, and decreasing on from 0 to pi over 2, and also 3 pi over 2 to 2 pi. Right, so it's actually, technically, we can actually include the endpoints. So I'll probably do that, but I think that WebAssign is asking for open interval, so you don't really have to, so you have to put the parentheses. Right, but let's type this guy in. Alright, so find the interval in which f is increasing. So that was between pi over 2. So let's see. I'm going to put, let's see, pi. Right, I have to put a Greek letter. Pi over 2. And then you have 3 pi over 2. Right? And then you have a parenthesis. Right? So that's the interval on which f is increasing. Actually, for the heck of it, I'm going to actually put the square bracket, see if the Weber sign takes that answer. All right, technically this is a correct answer. All right, then you have decreasing between 0 to pi over 2. So you have a pi over 2. Oops. All right, pi over 2. And then I'm gonna put a union, or actually maybe I'll just I'll just use a union. Here's sets, here's a union, and here we have 3 pi over 2 to 2 pi. Oops, that's not where I want it. Comma 2. Oh no. 3 pi over 2, then go here, then comma, and a 2 pi. Alright, so we have that. Alright, so I'm going to actually go ahead and check to see if they like that answer. Alright, so submit for testing. Alright, it came back and it looks like actually they took my answer. Alright, so those are the correct answers. Alright, part B. Find local minimum and the maximum value of f. Alright, so let's go back. Alright, so you can see that those are critical numbers. And so decreasing turn into increasing. So at this point, we'll have, right, so it's going down and up. So it's going to be a local minimum here. And after that, it's increasing, decreasing here. So this is going to be a local maximum. All right, so we need to, excuse me, we need to find the corresponding value. So f of pi over 2 is equal to, all right, so plug it in. So cosine of pi over 2 is actually 0. All right, sine of pi over 2 is 1, so it's negative 18. Right? And then let's see, f of 3 pi over 2 would be, all right, so if it's 3 pi over 2, cosine is 0 again, right? But the sine is going to be negative 1, so times negative 18 is positive 18, right? So what we have, right, local minimum is negative 18, and the local maximum is positive 18, right? So that was that. Let's do part C. Alright, so we want to find the inflection points. Alright, then we have to we want to discuss concavity here, concave up and a concave down. So we have to take another derivative. Alright, so let's do that. Alright, so we're gonna have to take another derivative. So I have to make some room here. So hold on, I'll be back. Okay, so we have to take another derivative. So I would probably start here. So this is the first derivative right here. Alright, so let's take the derivative of that. So f double prime of x is equal to, right, so negative 18 is just a constant multiple, so I'll just leave that guy alone, right? Then we're going to take the derivative using a product rule, right? So derivative of cosine first guy is negative sine, right? Times the second guy, so I'm going to put the sine of x plus 1, right? Plus cosine of x times the derivative of the second guy. So derivative of sine is cosine, derivative of 1 is 0, so you have another cosine. So I'm going to probably put cosine squared, because you have cosine times cosine. Then you have that. Alright, so looks like we have sine here. So I'm going to rewrite this guy as, instead of cosine squared is equivalent to 1 minus sine squared of x. Right? So let's combine that. So this is going to negative 18. Right? Then what you get is, let's see, you have a negative sine squared of x. Right? This times that is negative sine of x. Right here you have 1 minus sine squared of x. Right? So actually, I'm going to incorporate this negative sign to change the sign. So here, I'm going to distribute to this guy. So this becomes positive. This becomes positive. This becomes negative. Negative. And this becomes positive. Right? That way, we have, right, you have 18 in front. Then we can combine sine squared of x, and you have another sine squared of x. So you have a 2 sine squared of x. And then you have a plus sine of x and a minus 1. So that will take care of those two guys. All right. Then we can factor this guy out, hopefully. So 18. Then you can split as into 2 sine of x and the sine of x, then plus 1 here and a minus 1 there. Right? So you can see that the negative 1 times 1, negative 1. 2 times 1 is 2. Negative 1 times 1 is negative 1. So that gives us positive 1. Right? So we set that equal to 0 to find the x coordinates of a possible inflection points. Right? So let's do that. So from here, we have a couple of conditions again. Sine of x, we can see that we want it to be 1/2 to get a 0. Or sine of x is equal to negative 1. Right? So we can again play with the unit circle. Right? So if you want a unit circle, right, then we want sine to be 1/2. So 1/2 is right here. Right? So which means that this angle here, oops, that's not what I want, and this angle here, and that angle there, right? Which is, this is 30 degrees, this is 150, right? So this means that x is going to be equal to pi over 6, and also 5 pi over 6, right? And the sine is negative 1, so we've done that before. It's right here. So angle is x equals 3 pi over 2. All right, then we want to discuss the concavity. So we're going to do the number line again. So from 0 to 2 pi. So you have 0 here and 2 pi there. Right, then you have pi over 6 is probably here, and 5 pi over 6 is right before the middle, so it's 5 pi over 6. And you have, let's see, 3 pi over 2, so maybe somewhere around there. It's 3 pi over 2. Right, then we just need to examine the sign of f double prime. So we're looking at the f double prime. Alright, so again, f double prime, I'm going to pull it out here. So f double prime of x is 18 times 2 sine of x minus 1 times sine of x plus 1. Alright, so here 18 is positive, so we don't really have to worry about this. And this guy is actually always positive, except that it can be 0 when sine is negative 1. But that case is actually excluded. So this is, you can see that this is always positive. So we just have to worry about this guy. All right. So let's see, if x is smaller than pi over 6, right? So you can see that sine value is going to be smaller than 1/2. So which means that this is going to be negative there. All right, so we know that this is negative there. All right, so this is going to be between pi over 6 to 5 pi over 6. All right, sine of x is going to be bigger than 1/2, so it's going to be bigger than 1/2, so that's going to be positive there. All right, so you're going to get the positive sign here. All right. After 5 pi over 6, then you can see that sine is going to be less than 1/2, so it's going to be negative there. So that's going to be negative there. So we have a negative sign here, right? After that, between 3 pi over 2 and the 2 pi, so we're talking about this angle right here. But still, you can see that this is actually going to be a negative sign value. So that's going to be negative, and this is positive. So the sign is actually negative again there. All right. So in terms of inflection points, you can see that there's a concavity change here. So here, if second derivative is negative, right, then you have a concave down shape. Second derivative positive, you have a concave up shape here. Here, it's concave down, and it's again concave down, right? So you can see that there's a concavity change at pi over 6. So you would have an inflection point there. And also, 5 pi over 6, you would have inflection points there, right? So we need to find the corresponding function value. So let's try to find that. So let's see, I'm going to make some room here. Alright, so we have to find the corresponding y-coordinates at pi over 6. So I plug in pi over 6 there. Alright, so this is going to be 9 times, actually I'm going to just say 9 times, right, cosine of pi over 6 is square root of 3 over 2. So square that, it's going to be 3 over 4. Alright, minus, alright, pi over 6 sine is going to be negative, sorry, 1/2. So it's going to be negative 2 times 1/2 is negative 1. Right? So that would be negative 1/4 times 9, so negative 9/4. Right? And f of 5 pi over 6. Right? So it's going to be 9 times. Cosine 5 pi over this is 2, right? Oh, sorry, 6. 5 pi over 6. So cosine value is negative square root of 2 over 2, but it gets squared. So it's going to be 3 over 4 again. So you have 3 over 4 as before. And the sine value is going to be still 1/2, so negative 1. So it's actually exactly the same thing, negative 9 over 4. All right, so here's the critical points. Let's type it in. All right, critical points happens at the pi over 6. So Greek letter pi over 6, and then comma. Then you have a negative 9 over 4. All right, and the other one is 5 pi over 6. comma, over, let's see, how do I do it? All right, over 6 and comma, negative 9 over 4. Right? So those are the critical the inflection points. Then we can look at the concavity, right? So interval on which f is concave up. So let's go back and take a look. All right. So concavity here. So we know that the f is concave up on. All right. So here between pi over 6 to 5 pi over 6. And other than that, it's concave down. So then concave upward, downward on, right, from 0 to pi over 6. All right, and 5 pi over 6 all the way to 2 pi. All right, so let's put that in. All right, so here, concave up between pi over 6, so pi over 6, and with the parenthesis, and then you have a 5 pi over 6. All right, and here you have 0 to pi over 6, pi over 6, and then take the union, and then you will have pi over 5 pi and over 6 to 2 pi. All right, so we have that. All right, let's submit for testing. All right, it came back and it was pretty long, but we got part B correctly and part C correctly. Those are the inflection points, and we got the concave up, concave down intervals. All right, that's it. I hope that this was clear.